Solutions to work and power questions. So what we're going to do is going to start off just by looking at these. These are quite easy ones really, but in each case we need to work out work and power or use the equations that you've got there, so you have to manipulate them. So first thing I'm going to do is I'm going to write down work done. I'll call that WD. So I don't mix it up with W for weight, which is generally lowercase, and it's equal to energy used, which is equal to force times distance, and then I've got power, P, and that's equal to, well, it's the rate of doing work, how quickly you do work, so it's work done over time, and since work done is equal to energy over time. So moving on then. So 1A, we are going to book FIFA throughout these examples. So boy lifts a 2 kilogram box on a shelf to a shelf 1.5 meters above the ground. What is the work done? So I'm finding the work done, and I've got 2 kilograms and 1.5 meters. So I need to find work done, WD, and the mass in this case is 2 kilograms, and it's 1.5 meters. So distance, in this case displacement, S is equal to 1.5 meters. So work done is equal to force times distance. If you can remember, that distance here is actually displacement. So it's force times displacement. So, but I haven't got force. What I've actually got is a mass of 2 kilograms. But I do know that a force is weight, which is equal to mass times gravity. So I can now find the force needed by substituting in mass, which is 2 kilograms, times 9.8, which is the acceleration due to gravity. So now we've got 18 and 19.6. So I have a weight or a force equal to 19.6 newtons. So I can now do work done is equal to force times displacement. So I can now insert my numbers. I've got 19.6 times displacement, which is 1.5, and that is equal to 19.6 times 1.5, and that's equal to 29.4. Now we're trying to find work done, which is energy, let's measure in joules. So it takes 29.4 joules of energy to lift a 2 kilogram mass onto a shelf that is 1.5 meters high. So moving on to part B, 1B, now asking me to work out power. So if this took 5 seconds, what's its power? So box underlined. So power equals question mark. And now I've got time is equal to 5 seconds, and I've also got from this answer here that the work done to get energy transferred is 29.4 joules. So power is equal to work done divided by time. Insert my numbers. So we've got 29.4 divided by 5. It's actually equal to 5.88. Power, so let's do watts. Right, moving on. Question number 2. So this girl took 5 seconds. What is his power? No, sorry. A girl pushes a table with a force of 40 newtons, a distance of 3 meters across the floor. What is the work done? So maybe we should run this one first because it's a lot easier. What's the work done? So box, underline. So work done. We don't know. We do know the force is 40 newtons. Distance d is equal to 3 meters. So formula, work done, force times distance, insert 40 times 3, that's 120 work done, so it's joules. Now 2b is asking if she has a power of 24 watts. So we're finding, she has a power of 24 watts, how long? How long will it take? So we're given power of 24 watts and we need to find time. Don't know what it is. We do know that work done is actually from here is 120 joules. So what we got then? Formula, power is equal to work done over time, insert 24 is equal to 120 divided by time. So I want to make time the subject. A little bit long-winded then. So I'm going to multiply both sides by time. And it'll cancel on the right side, on the right hand side. So that will leave me with 24 times t is equal to 120. I'm now going to eliminate t the subject here and leave it here. So I'm going to go with dividing both sides by 24. So we end up with t is equal to 120 divided by 24, which in this case is 5 seconds. Underline that. So now I'm not going to do question number 3, which is this one here. A man uses 100 joules of energy lifting a bag of shopping onto a 1 meter high table. What is the weight of the bag? So think about what we did here with question number 1 to find weight. Okay, and then you can, if you can lift a bag 10 times, lift 10 bags in 20 seconds, what's his power? So this one to do. Now, what we are going to do now is we're going to move on to do a couple of these examples. So what we've got here is in the PowerPoint, there's a number of questions. So I'm not going to do them all. I'm going to let you do the one with squiggles. The answers are on the next slide anyway, so you can check. I'll let you do the one question number 4. So I'm just going to do questions number 1 and 2. What we've got then? Get a bit of focus. You're going to focus. Oh, there we go. So Alex Rutten's up a 2.9. There we go. So Alex runs up a 2.9 meter high flight of stairs at a constant speed of 2.15 seconds. If Alex's mass is 55.9 kilograms, determine the work which he did and his power rating. So what we need to do is we're going to find work, and then we're going to find power. So I'm told that it's a 2.91 meter high flight of stairs, but a constant speed of 2.15 seconds, and Alex's mass is 55 kilograms. So let's go. So I need to find work done. And my information is that we have constant 2.91 meters height of stairs, so displacement is 2.91, and I've got a mass of 55.9 kilograms, and I'm also told that we've got constant speed of 2.15 seconds, so velocity is equal to 2.1. That's constant speed. Well, that should be constant and takes in 2.15 seconds. Okay, sorry about that with the question. Yeah, shouldn't be. Alex runs up a 2.91 meter high flight of stairs and it takes 2.15 seconds. This is time. So we need to find work done first, and then we can find power here. So formula, work done is equal to force times displacement. So what's happening here then is Alex is running up a flight of stairs. Yeah. Now the vertical height of these stairs is 2.91 meters. Okay, and it takes him time of 2.15 seconds. He has a mass, as Alex, of 55.9 kilograms. So he's running up these stairs to the vertical height, 2.91 meters. He's got a mass 55.9, and it takes him 2.15 seconds. So we've got work done equal to force times displacement. So we know displacement here. We don't know force. What we do know though is that Alex's mass is 55.9. So force is equal to weight, which is equal to mass times gravity. So we've got 55.9 times gravity, which is 9 point gravitational field strength, which is 9.8. So that's going to be 55.9 times 9.8. 547.8 newtons. So what we've got then is we now know force and we know displacement, so we can say that work done is going to be equal to the force, which is 547.8 times displacement 2.91, which is equal to 1594 joules. Now that gives me work done, and I need to calculate power. Now power is equal to work done over time. That's going to be to 1594 divided by 2.15 seconds, which is equal to 741.6 0.468, so we'll call it 0.5 watts. So what's his power output as he runs up those stairs? So question number 2. On a recent adventure trip, Laura went rock climbing. Laura was able to steadily lift her 45-kilogram body 20 meters in 100 seconds, determining Laura's power rating during this portion of the climb. So we're finding power. What the power is, but I've been told that her mass is 45. If she lifts her body 20 meters, so displacement is 20 meters, and the time is 100 seconds. So we have, if we sort of have our rock face here, there's Laura, and she starts here in position 1, moves up 20 meters to get to position 2. Her mass is 45 kilograms, and it takes her 100 seconds to move from here to here. So power is equal to work done over time. I've got time, but I don't have work done, so I need to calculate work done. I know work done is equal to force times displacement. So I've got displacement, but I don't have force, but I do have mass, which is 45 kilograms. So what we can say is that force is equal to weight, which is equal to mass times gravity, which is equal to 45 times 9.8, which is equal to 45 times 9.8, and that's equal to 441. That's weight, so that's newtons. So now I've got force. I can now calculate work done. So work done is equal to 441 times displacement, which is 20 meters. So times 20, so that's equal to 8820 joules. I've now got work done. So I can look at power is equal to work done over time, which is equal to 8820 divided by 100, which is equal to 88.2 watts. And I'll add it twice. Now, that's question 1 and 2 worked out. I'm going to leave you to work out question number 3 and 4. The answers are actually on the slides, on the following slides. So you will need to work out question number 3 here and question number 4. And question number 3 is quite involved, but I'm sure if you put the effort in, you'll be able to find out how much power my squirrels put out. They're out there doing it now. Okay, this is why the radio is running. They stop working, my radio stops working. So question number 4, and then what you'll notice on the next slide is the answers, so you can check. But the answers are worked out. I think I used gravity as being equal